Creating accurate machine learning models capable of localizing and identifying multiple objects in a single image remained a core challenge in computer vision. But with recent advancements in deep learning and deep learning based computer vision models, object detection applications are easier to develop than ever before. So guys, I Kisler from Edreka welcome you to this session on object detection using TensorFlow. So before moving forward, let's have a quick look at the agenda of this session. So first of all, I'll be starting with explaining you guys what is exactly object detection. Then we'll have a look at the object detection workflow, how exactly it works, and the various industrial use cases of object detection. Then we'll understand what is TensorFlow, and I'll end this video with two demos. The first one being the TensorFlow object detection, where we can detect objects using our own input images. And the second demo is based on the live object detection, where we'll detect objects in real time. So without wasting any time, let's go ahead and start. Now, object detection allows for the recognition, detection, and the localization of multiple objects within an image. It provides us a much better understanding of an image as a whole as opposed to just visual recognition. In addition, with current approaches focusing on full end-to-end pipelines, performance has also improved significantly, enabling real-time use cases. Object detection is the process of finding instances of real-world objects such as faces, bicycles, and buildings in images or videos. Now, object detection algorithms typically use extracted features and learning algorithms to recognize instances of an object category. It is commonly used in applications such as image retrieval, security, surveillance, and advanced driver assistance system, which is known as ADAS. Now let's have a look at a few of the object detection applications. Now the first use case is the facial recognition. Now popular applications include face detection and people counting. Have you ever noticed how Facebook detects your face when you upload a photo? That is due to their facial recognition algorithm. Now this is a simple example of object detection that we can see in our daily life. Even the DSLR cameras and our phone cameras also detect the faces. Object detection can also be used for people counting. It is used for analyzing store performance or crowd statistics during festivals, where people tend to get lost easily. Now these tend to be more difficult as people move out of the frame quickly and also because people are non-rigid objects. Object detection is also used in industrial process to identify products. Finding a specific object through visual inspection is a basic task that is involved in multiple industrial processes like sorting, inventory management, machining, quality management, packaging, and much more. Inventory management can be very tricky as items are hard to track in real time. Something is always added, removed, and moved every day. Systems can perform automatic object counting and localization that will allow you to improve inventory accuracy. Now, this is one of the most recent and I should say one of the most exciting use cases of object detection, which is the self-driving car. It is a vehicle that is capable of sensing its environment and navigating without human input. Now, how is it done? Now, it combines a variety of techniques to perceive the surroundings, including the radar, laser light, GPS, and also computer vision. Now here is where the object detection comes in place. So the moment it senses a person on the road on its way, the car automatically stops. Advanced control system interprets sensory information to identify appropriate navigation paths as well as obstacles. Now our final use case is the most important one, which is the security. Now it is used in the banking industry as well as the phone industry, or I should say the technological industry a lot. So it is used in the banking industry to identify fraud, the forgery of notes or the currency, and also theft. Now one of the most important use of object detection is the facial recognition used in the smartphones nowadays, which is popularly known as face unlock. Now that we have understood what are the various industrial use cases of object detection, let's have a look at the object detection workflow. Now typically there are 3 steps involved in object detection workflow. First of all, we have the training data, which we input and create our model. Now this model is created using the visual features which are extracted from the images or the digits or whatever be your input of the training data. Now these are evaluated and it's determined whether which objects are present in the proposal based on the visual features. Now upon extracting these features, We have a classification model created. Now, after that, we have the testing data. In our final post-processing step, we use the testing data and we extract all the features. And then we move on to our model to see which all features are matching which type of class. And finally, after the computation is done, we finally get our result. Now, there is an important trade-off being made here, which is between the number of regions versus the computational complexity. We'll learn more about these later in this video. Now, in object detection frameworks, people typically use pre-trained image classification models to extract visual features, as these tend to generalize fairly well. The goal of feature extraction is to reduce a variable-sized image to a fixed set of visual features. Image classification models are typically constructed using strong visual feature extraction methods, whether they are based on traditional computer vision approaches such as the filter-based approach, the histogram methods, or the deep learning methods. They all have the exact same objective, extracting features from the input image that are representative for the task at hand and use these features to determine the class of the image. Now that we have understood the basic workflow of an object detection algorithm, let's go ahead and understand what is TensorFlow. Now TensorFlow, as you can see, is divided into two parts, which are the tensor and flow. So let's understand what is tensor first. So tensors are the standard way of representing data in deep learning. Now tensors are simple arrays of numbers or functions that transform according to certain rules under a change of coordinates. They are just multidimensional arrays, which are an extension of a two-dimensional table to a data with higher dimensional. TensorFlow, as the name indicates, is the framework to define and run the computation involving tensors. So as you can see, we have a tensor of dimension 6, then we have a tensor of dimension 6, 4, and finally we have a tensor of dimension 6, 4, 2. Now these dimensions are not limited to 2, it can be multidimensional. Now in TensorFlow, the computation is approached as a data flow graph. TensorFlow can run on multiple CPUs and GPUs with optional CUDA and SYCL extensions for general purpose computing on graphics processing unit, and TensorFlow, its flexible architecture allows for easy deployment of computation across a variety of platforms, which are the CPUs, GPUs, and the TPUs, and from desktops to clusters of servers to mobile and edge devices. Now, TensorFlow computations are expressed as stateful data flow graphs. The name TensorFlow derives from the operations that such neural networks perform on multidimensional data arrays, which are known as the tensor. Now let's see how object detection can be performed in TensorFlow. So first of all, we provide our input data, which is a set of images, and using TensorFlow, we train our model. Now this model is trained using deep learning, and the main objective of this model is to extract the features. Now these are visual features which are based on edge detection, the HAR features, the facial recognition, and many more. Now, when these features are extracted and then the model is created, to test this model, we provide our test data, which is again a set of images in our case. And using this model, we get our final output in which we have the objects detected in an image. Now, the images are converted into a NumPy array in the TensorFlow object detection so that the computation can be made easy. We also use the TF record, which is the TensorFlow record, which contains the record of the image along with the tags, such as you can see here, we have the person tag, we have the dog tag, and the horse tag. Now, these tags are just labels which are provided in the input data. Now, let's go ahead and start our demo and see how we can perform object detection using TensorFlow. Now, to begin with, you want to make sure that you have TensorFlow installed with all of its dependencies like the TensorBoard, Python, Matplotlib, we have the Cocoa API, and the protobuf. Now, I'll explain you guys what all steps are needed. So for CPU TensorFlow, you can just do pip install TensorFlow, but of course the GPU version of the TensorFlow is much faster at processing, so it is ideal. Now, next we need to do is to clone the GitHub repository of TensorFlow. So for that, just go to GitHub and type TensorFlow, which is the official GitHub repository of TensorFlow. And inside that, we have the models section. Just go to this models. You can either clone this TensorFlow model or download it as per your wish. So I have already downloaded the TensorFlow model. Now, the TensorFlow object detection model uses protobuf to configure model and the training parameters. Before the framework can be used, the protobuf libraries must be compiled. Now, to download protobuf, all you need to do is go to Google/protobuf in GitHub, and here you will have all the different versions of protobuf. So according to your OS, which is Linux, Mac OS, or the Windows OS, or if you are using only the Python, you can download the required protobuf. So once you have downloaded TensorFlow and protobuf, create a folder in just C, which is known as TensorFlow, and in this you'll have the models master. Extract this and rename it as models and extract the protobuf. Now inside protobuf you have the bin folder. Now all you need to do is go to this bin folder. So let me just open the command prompt. Here I am using the Anaconda prompt, but you can use the command prompt as well. So once you have downloaded and renamed the models master as models, go back to the GitHub repository, and inside models you have the research, and inside research there is the object detection model which we are interested in. So let's go to the object detection model here. Now as you can see, this TensorFlow object detection API gives an accurate machine learning model description of how the objects are detected, and here you have the steps for the setup. So in the installation, as you can see, we have the prerequisites or the dependencies, which are the protobuf, Python, Pillow. You can install all of these using the pip or the conda command. Okay. So to download the protobuf on Ubuntu, you can do the sudo apt-get install. Then you can use the Cython, the contextlib, the Jupyter, and the matplotlib. Alternatively, you can also use the pip and the conda commands. Next, what you need to do is once you have downloaded and extracted the protobuf, you need to copy this command. Now then you need to go into the TensorFlow, then you need to go into the models, and then inside that you need to go into the research. Now once you are inside the research, what you need to do is copy this command and paste it and run this command here. So what it'll do is, I'll explain here, is that it'll take all the object. If you go inside the models research, and inside if you go to the object detection, you can see there's a folder named protos. So once you have compiled that code, all the proto files are then converted into the Python files. Now in order to have a better understanding of what the different supported components are, inside the protos folder, which contains the functional definition, especially the train, the eval, the SST, the faster RCNN, and the processing protos, which are important while training a model, all these proto files are present here. What you need to do is that run that command, and all the protos file will be converted into Python executable files. Now after that, what we need to do is Cocoa API installation. Now let's understand what is Cocoa. Now Cocoa refers for common objects in context. It is a large image dataset designed for object detection, segmentation, person key points detection, stuff segmentation, and caption generation. Now this package provides MATLAB, Python, and Luna APIs that assist in loading, parsing, and visualizing the annotations in Cocoa. As you can see, we have 330K images, in which we have more than 200K labeled images. We have 1.5 million objects instances, 80 object categories, we have 91 stuff categories, 5 captions per image, and we have 250 people with these key points. Now, when you have downloaded the models, inside models research and inside the object detection, you need to go to the G3 doc, in which we have the TensorFlow detection model zoo. Now here we have all the list of models which are trained on the Cocoa dataset. So as you can see, we have the SST MobileNet version 1, we have the SST MobileNet version 1 PPN Cocoa, Depth Cocoa, we have the SST Inception, we have Faster RCNN, we have different mask RCNN Inception. Now an important thing to consider here while selecting a model is that it depends on your system which model you should use. Suppose if your system is low on GPU but has higher RAM, you can go for a model which has a higher speed and a higher MAP point. Now this value should always be high if you're looking for a more accurate prediction in your images. So once all your dependencies are downloaded and you have installed TensorFlow and protobuf, let's go ahead and see how we can do the coding. Now inside the object detection folder, there is an object detection tutorial. Now, first of all, what we need to do is import all the libraries, the NumPy, the OS, the SYS star file. We are importing TensorFlow as well. We are importing the collections and the various imports which are needed. Then we need to append the path of the object detection folder. And finally, if the version of TensorFlow is less than 1.4, we need to upgrade it, as the latest tutorial supports the TensorFlow object 1.4 and above. So let's run this block by block. So first of all, let's load all the libraries. Now next, what we are going to do is import the object detection module, some of the labels, which are the label map util, which will be later used to provide the labels to the input images, and based on that our model will be created. Now next, what we are going to do is we are going to select which model to download. So for example, here we are using the SST MobileNet version 1 Coco 2017. So if you go back to the list of the models, you can select any of the given models here. But make sure your system should support the required amount of RAM, and it should have the required amount of GPU to support the models which you are selecting. So for this tutorial, I'm using a model which will give me the results faster. So all you need to do is provide the model name, the model file, and the download base from where it should download. Now, as I mentioned earlier, that TensorFlow works on the graph principle, which is the data flow graph. So what we are going to do is give the path to the detection graph, which we are going to use here, which will be supported by this model. And then we are going to give the path to the labels. Now to download the models, we have this code which will take the URL and which will download this file and produce the frozen inference graph of that model, which is the SST Coco MobileNet. So once this has been done, we are going to load the graph, which is the frozen inference graph, into the memory. So here we are using the tf.graph method and tf.graphDef to define the graph which we are going to use. Next, what we need to do is load all the labels and the categories and the category index from our data set. So the data set is Coco. So once we have loaded all the labels and the categories, now is the time to convert all the images to a NumPy array. So this code, which is definition here of the load image into NumPy array, which we'll use later in this code, what it does is takes the images and converts it into a NumPy array, so it will be easier for TensorFlow to process it. Now here we are going to provide the images for testing purposes. So as you can see, we have the test image folder here, and inside that you can input all your images, whichever you want to test upon this model. So for example, I have taken the range from 1 to 8. It will take all the images named image 1 to image 7. So let's load this. Now this function, what it does is run the inference for a single image. Now for a single image, first of all, it detects all the boxes, the detection mask, and provides a certain box on the object it detects. And finally, we have the for loop, the main for loop, in which we'll take the images from the test image path and open them, and one by one we'll take all the images and do the inference for a single image one by one. So as you can see, we are using the load image into NumPy array. We are using the np.expand. Now we'll expand the dimensions since the model expects images to have the shape, which can be 1, 2, 3 based upon the categories. And you can see the output will get the detection boxes, the detection classes, and the detection score. And finally, we are using the matplotlib to show us the image. So let's run this. We'll get our output here. So this might take time depending upon the processor which you are using or the system which you are using. So since we have taken the model which will take the least amount of time, this shouldn't take much time. But then again, TensorFlow is heavy, and the tensors are multidimensional arrays, as I explained, which do all the heavy computation. So guys, here we have the results. So as you can see, let's begin from the start. As you can see, it identified the dog as a 94%. It has provided a box, the label, and the score, which is the detection score, how much it is similar to all the images which has been inputted in the Coco dataset. So as you can see here, we have the person, the various percentage, We have kite. Here we have a tie detected. It can detect objects in such a heavy background. As you can see, the person are so much camouflaged in the background, but still it has managed to score that person. As you can see here, it has detected an airplane, person, kite. Now you can use your own images. All you need to do is copy that images into the test image folder and use the naming convention provided here as the image 1, image 2. So now let's go ahead to our second demo, which is the live object detection. Now in this demo, we will use the OpenCV. So let me show how we can do the coding here. So first of all you need to do is copy all the code and paste it into another Python file. So once you have pasted, the major changes which are involved in the live detection of the images is that we are going to use OpenCV. So first of all, we need to import CV2 here, as you can see, and we have defined an object CAP that will capture. So we are going to use CV2.video capture. Here you can change the model which you want to download, because if you have a higher GPU and the refresh rate of the images is also high, you should take a model that has an equal balance among the speed and also the accuracy of the image detected. So all this will remain same, and I'll show you what all changes we need to make. So what you need to do is, for image path in test images, as you can see, we do not need this code because our images will be not coming from the test image folder, as it will be coming from our webcam. So you need to remove these codes, and instead of that, you need to do is input these line of code, which is while true, return, and we'll use image np as that's the exact name which is being used here by the TensorFlow code. And we are going to use cap.read. So what it will do is it will take the input of the video which is coming through the webcam, and then we need to remove these two lines as well, which is the plt.figure and the plt.image_show, because we are not using matplotlib anymore and we'll be using the OpenCV. So we'll do cv2.imshow, and this is the name of the window which will come up. And for instance, we are resizing it, the image to 800 is to 600. Now we need to provide this code as well. Now what we'll do, it is the wait key option of 25 seconds, and if we press Q or for 25 seconds the screen is black, it will automatically destroy all the windows and break out of the loop. So here you do not need to run this code, which is the path to the test image, because it's not needed. You do not need to convert the images into the NumPy array, because all the images coming through the OpenCV is already in an array format or a structured format. So let me just open another console for you. So first of all, we'll import all the necessary libraries, the CV2, we have the TensorFlow, we are going to import the label APIs and the label frameworks which are used here. Now we have already downloaded this model. What you can do is again run this code, but that won't help either. Next, you need to load the frozen inference graph. After that, we need to load all the labels. And finally, we need to run our final code block, which is the object detection, which will call all the definitions which I have provided earlier. So guys, as you can see here, it has opened up a window of 800 cross 600. And as you can see, it has successfully detected the TV as 92% of TV, and keyword also has been detected at 90%. So as you can see, it is also detecting the bottle which we have provided here as 92%. It is also detecting the cup as well. So what about the phone? Let's see if it detects it as a cell phone or not. Let me just keep it in the frame. As you can see, it has detected cell phone. Now the refresh rate of this particular model is slow because we needed the result fast. But if you have a higher GPU system and the CPU is good, you can use more advanced model with a higher refresh rate. So as you can see here, it has detected clock, the watch as clock. And the moment it receives any part of human body in the frame, as you can see, if my hand is there, it will detect it as a person. Okay, you can see it is detecting the TV, the cup. It will also detect the phone as well, the cell phone. So as you can see here, it is also detecting the chairs. So as you can see, it has also detected my chair as well. So guys, as you can see, it has also detected me as a person. That is good to know. So guys, with this we come to an end to this tutorial of TensorFlow object detection. So I hope you guys learned a lot about the object detection, how it works, how TensorFlow works, what is TensorFlow, a brief introduction to it, and how we can use the TensorFlow models which are generated with the Coco dataset or the Kitty dataset, whichever dataset we want. So it can be used to detect objects in real time as well as objects in the input images as well. So guys, go ahead and try this example and let me know if you were successful or not, or the challenges which you are facing. List down in the comments below and I'll make sure I'll respond to all the comments. And in my next video, what I'll try to show you guys is that how you can create your own image classifier. Here we are using the pre-trained model of TensorFlow, but in the next video, what I'll try to show is that how you can create your own model with your own image dataset. We can split the dataset into training and testing, and then we can create our own model. So guys, thank you so much for watching.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to EduReka channel to learn more. Happy learning!